Hello, friends, and you can see the program guide, the viewer guide is given here with the timestamps. So, if you're looking for some subject which is very specific, which you would like to watch, you can actually return at that time. So there are few comments that I have seen, and they are for the next program. So I look at the timestamp and then join back again. This section is for the science buff. So let's begin our science understanding, and today we are going to discuss something very interesting, and what that thing is going to be. It's about basically identifying life in our solar system and beyond. Now we are actually seeing that there are several exoplanets. Nearly 5,000 have been detected so far, and these planets, which are exoplanets, are the planets not around the sun, but they are revolving around other stars in the neighborhood. Now we have identified 5,000 planets. Although the galaxy is a huge, large place, there are many planets. And we now know that there could be trillion stars in our galaxy, so there could be multi-trillion planets. However, our limitation is basically because of the technology that we have, and based on this limitation, we have been able to see only 5,000 planets so far in very close vicinity of our sun. Nevertheless, even in this small footprint, we have been able to find nearly 17 planets which could harbor life and which could have liquid ocean. So what determines, and we know water is very important for life, as we have seen, because the liquid water exists on Earth, and so far we have not been able to detect any life in any other planet within our solar system. So liquid water, presence of water, may be important for kickstarting the life. So if it has happened on Earth, it could happen on one of the exoplanet which is out there. And now among these 5,000 planets, scientists have found that there are 17 good candidates which could have liquid water, huge oceans, maybe water world. So 17 are there, and we are going to discuss about how we can identify that there is water on those planets, etc. So before we start, let's look at some basic data. The green belt that you see here is the area around each star, described as the habitable zone. Now when we talk about habitable zone, this is something which is where there could be existence of water. So far our driving force has been look at the water, where the water could exist in the liquid form, and the water can exist based on the distance from the star, because it's neither too hot, because if it is too hot, as you can see in the middle, the close orbits, the planets which are orbiting very close to the star, will have high temperature, and the water will evaporate, may not exist as liquid. And if you go beyond this green zone, then water will actually freeze up and will not be available in the liquid form. So we know this, and depending on the size of the star, the habitable zone will the size of the habitable zone also increases. As you can see, if the star is small, the habitable zone is much closer to the star. If the star is the middle size, just like our sun, habitable zone is where the Earth is. And if it is a much larger star, then habitability will be widespread in the outskirts of the star system. Not really outskirts, but it has to be very far off, because at that distance only the liquid water will be able to exist. So now we have figured out that there is a mechanism, and if we are looking into these areas, then we may find a planet with rich water, oceans, rivers, lakes, and also weather system. So I think that is the first thing. However, the other ingredient that is required for life to kickstart is carbon, because carbon, oxygen, hydrogen, nitrogen. These are the four elements. These are the first four elements which are required for life to kickstart, because we are all made of carbon, nitrogen, oxygen, and hydrogen. Hydrocarbons, as we call it, all the biology is made of hydrocarbons, and water is the medium where everything get mixed up and the permutation combination happens. So we essentially, these elements are very abundant across the universe. So if there is water on those planets, the chances are there will be carbon, there will be nitrogen, there will be hydrogen, there will be oxygen, very, very abundant material. And therefore, if the life started on Earth, there is no reason that it cannot start on the other exoplanets where there is water on the surface. So let's look at what are the other parameters that may be important. We have discussed water, we have discussed carbon, we have identified the habitable zones where we should look when we are looking into outside the solar system, at other solar systems which are outside and very close by within the galaxy. So this line is the frost line, as we know. So after the habitable zone, then we hit an area in a solar system which is called frost line. The frost line is a line or is a boundary where beyond that water will freeze up, as we have seen in the case of moons of Jupiter and Saturn, and all the planets which are outer planets, that they although these are gas giants, however the satellites which are present on these planet revolving around these planets are all frozen up. So there is a lot of water on moon of Jupiter like Europa, but as you can see, it's kind of frozen up completely. And now scientists have already confirmed that there is a subterranean huge ocean, and on Europa there is so much water that it is almost 3 times the size of the Earth's ocean. Europa is slightly bigger than Moon. You can imagine that there is a huge ice crust on the surface which is protecting the interior from the outside radiation. So it's all frozen up, but inside there is liquid water. That means temperature may be higher, and there is a lot of water. That means there is more permutation combination possible. So now, considering this data that we are understanding about our own solar system, we may have to increase the size of the habitable zone, because there could be life found within the these planets which are even outside the frost line. So that is the latest understanding, and therefore we have to also look at other lines which may be important, because we know that there is liquid water in the habitable zone. Before that, there is no water at all because the temperatures are so high. After the frost line, there could be still chance of life coming up. If there is a similar situation happening elsewhere in any other solar system, we should be confident enough that there could be life on those moons of those gaseous giants. So the other area that we are looking at, we are increasing our horizon when we are trying to find possibility of life, is basically going beyond the frost line, and now we are looking at the soot line. Soot line is the line at which the carbon freezes. So if there is ocean, if there is an ocean protected by ice crust, but if there is a lot of carbon, the chances are we will be able to find life on those planets. So this is something which is now being worked upon. We are now looking at increasing the search criteria, and we are now looking at the soot line. Soot line is the line of carbon. When you light a candle, you will see the carbon deposit around it, which is black in color. So that is called soot line. So in the solar system also there is a soot line. Beyond that, the carbon will be too much frozen. It will not be available for mixing around in the liquid ocean, etc., because the temperatures are too low. So this way we can extend our search criteria and not only look for water but also look for abundance of carbon, because if carbon is there, hydrogen is omnipresent, carbon and hydrogen can merge together and can form life, ingredients of life. And we also know that nitrogen is also very abundant in the space, because if you see Pluto, which is so far off from the sun, but it is entirely made of liquid frozen nitrogen. So nitrogen, if it is available so far off in our solar system, it would be abundant in our solar system also. So we have determined that we have to extend our search criteria, and now within our solar systems we have identified that these are the bodies which have liquid water on their surface. Now Earth has a liquid water on the surface itself, no need for extra protection. However, if you go beyond Jupiter and go beyond Mars, if you look at Mars itself, Mars mean temperature is minus 50, minus 60 at the equator. So when you look at Mars, the temperatures are already very low. But if you go beyond that, then there is a huge crust, icy crust, which is there, and after the icy crust there is an ocean. And because the temperature is not that low that the carbon completely freezes up. So if there is liquid water, there is carbon, nitrogen, oxygen, hydrogen, the possibility is that these oceans may have life. So a lot of research is being done at this point in time, and we know that the Clipper mission has been planned for study the exterior planets and their satellites to see if this could be life. Because if we find life within our solar system, it's going to be exciting, very exciting, because there will be not only one chance of life coming alive on a planet called Earth, but there could be 2 chances or 3 chances where, independent of Earth system, life could have evolved within the subterranean oceans on those satellites of the gaseous giants, where there is liquid water and conditions suitable for life to kickstart and also thrive. So this kind of information will be very useful for us to look at other exoplanets where there are similar conditions. And so far we should not only look at the habitable zone, we should also increase our horizon of basically identifying if there are soot lines in that solar system where there could be possibility of similar conditions like our solar system. For example, this is a artistic depiction of the cryovolcanoes. Now these cryovolcanoes have been studied by our Galileo probe when it was visiting Jupiter, and organic compounds have been found in this steam. Now when we say cryovolcanoes, these are the volcanoes which are basically coming out from the frozen ice. So their ecology or their geology is completely determined by the temperature variation within ice itself, and there is a subterranean ocean which actually shoots out from this cryovolcano without converting into steam. So it does not require too much temperature to kickstart the cryovolcanoes. These cryovolcanoes have the fumes of these volcanoes have been studied by Galileo, and it has confirmed that this steam or this fume contains the biological compounds. More research is required, but if this is happening after 4.5 billion years within our solar system, why it should not happen on other exoplanets? So I think that's a good enough information for us to look and increase our horizon when we are looking for life. So far, scientists have confirmed that there could be 17 exoplanets which could harbor life. Some are super Earth, which is like many times bigger than Earth, rocky planets, and some are smaller. But these are some of the very strong contenders, which is WASP 6b, Kepler 186f, and others, which are very, very strong candidate for having liquid ocean and possible life, because if there is water, there could be possibility of life being existing on these exoplanets. So it's very exciting. Today's study is very exciting. We should look at how the life would be on other planets, what are the conditions for life to exist, and we should actually extend our horizon from not only looking at the liquid water, but also extend our horizon and look at the conditions where there is liquid water, not on the surface but in the subterranean ocean, where there could be a different kind of life, different kind of conditions under which the life can evolve. So friends, this is a science topic today. I will take a very short break, come back in the business tips section. Don't go anywhere.